All right, guys. So we're going to just do a brief little intro to the National Synchrotron Light Source too. I know I've spoken to you guys a lot about this in the past. I just wanted to kind of touch base on this because one of the videos you'll watch talks about one of the newer synchrotrons, which is located in Great Britain. Um, National Synchrotron Light Source is tremendous. Inside of this ring is an open area that Yankee Stadium can fit inside of. That's how big this structure is. This is the main entrance to the light source, and the two buildings that are over here, one on the left, one on the right, these are the two buildings. They're known as LOBs, known as lab office buildings. In addition to office space, there are labs, and actually the labs kind of run right along this area here. We see these big ventilation areas. That's where they have vents for the fume hoods in the labs. We've done a tremendous amount of protein work in the labs here, and now they've actually opened a lab on this side for us. So pretty much all of our protein crystallography work that we do at the lab happens in this building. That's known as LOB 745. Okay, this is one of, if not the brightest lights on the planet in terms of generating X-rays. Okay, and the way that the synchrotron works, if you look at it from overhead, um, over here, buried underground. It's kind of interesting that it's buried underground, but there's a very decent sized ring here. This is the accelerator ring, and this is what boosts the electrons up to almost the speed of light, 99.9% the speed of light. And then they enter into a tube system that basically forms a ring that goes all the way around. Okay, we actually ride bicycles to go from building to building here. Okay, and these electrons move. It looks like a circle, but it actually has little angles to it. And each time you approach an angle, the electrons, what they do is they are bent using magnets, and that magnet slows down the electron a little bit. And as it does that, it releases light energy, and the energy that it releases is in the form of X-rays, which we can't see. And so these electrons just kind of move around here all the time. They're constantly reloading them. They're constantly keeping the beam going. This facility runs 24 hours a day, 7 days a week. It does shut down for a decent period of time, 3 times a year, so they can do maintenance. One of the really cool things is that they have these huge tanks of liquid nitrogen out here, which supply the entire building with nitrogen. And there's also an underground road here. This road goes underneath the building, so they actually have a little bridge so that they can deliver important materials here. Um, when you take a look at this with the overlay, you can kind of see this is a map of all the beam lines overlaid on top of that picture. And so again, here's building 745. Here's where we do all of our protein work. And then here's the booster ring and the LINAC, which is called the linear accelerator ring. And that's going to boost the electrons up to near the speed of light, and then they get released in here, and they move in this direction. And as they move in this direction, you see all these little lines coming off of here. Those are called beam lines. They're perpendicular to the actual main ring. And these beam lines capture the light energy in the form of X-rays, and it allows scientists to do work. At the end of each of these beam lines is a little thing called a hutch. And that little hutch is where there's all sorts of electronic equipment and detectors, and that's how we collect information on proteins. Basically, what this is a gigantic microscope, and we're using the X-rays to look at the minute detailed atomic structure of molecules that you can't see with regular light energy. Okay, this is what the entire facility looks like without the map on top of it. And we actually do the majority of our work right over here. Okay, but each of these beams are made up of these beam lines, rather, they're made up of these lead tubes that contain the electrons as they're moving out, and it captures the electrons' energy as X-rays. And then there are different types of filtering mechanisms that we can use to focus the light to the specific wavelength of energy that we want. Okay, but again, the booster ring's over here; it's underground. This is the linear accelerator, and what this does is there's basically like a gigantic spark plug that generates the electrons, and the electrons get shot in here, and then they go into this booster ring, which has magnets in it, and it allows the electrons to accelerate, and they get faster and faster, and then they get injected right here into the main ring. This ring, the electron energy in here is very high, and it's actually surrounded by walls that are 6 to 8 feet thick. and that prevents a lot of the energy from coming out. And within that tube, they're contained in lead. Now, the electrons themselves, when they're collected and release energy as X-rays, these are the two beam lines that we work at. They're in this building here, and the beam lines come right up to the end over here. And then there are all kinds of equipment and experimental hutches that collect data. Okay, these are the electromagnets of the storage ring, and you can see that there's a tube here. This is made out of lead. Okay, and these are these giant electromagnets, and the tube has a vacuum in it, and the electrons move in this tube. Okay, and as they move through this tube, these magnets cause it to accelerate and bend and turn, and that's what promotes the movement of the electrons. One of the really more powerful magnets are these what are called sextapole magnets. They have 6 magnets surrounding this central piece, and in this central piece here, this is where the tube would be located, the lead tube with the vacuum in it, and that's where the electrons would be accelerated. And it's these magnets, very powerful magnets, that permit the electrons to accelerate and maintain their speed at 99.9% the speed of light. Okay, and we harness that energy and we use that energy to look at proteins. And so all of those protein structures that you guys struggled with and looked at, those were all determined using X-ray energy coming off these beam lines. And then that X-ray energy allowed us to get a diffraction pattern so that we could see exactly what the protein looked like. The next bunch of videos that you look at this week breaks it down nicely as to how scientists actually do this and analyze it. And there are really 3 pieces to this. There's the wet lab part where we collect our proteins. Then we shoot them with X-rays and get the structure and diffraction patterns. And then we use computers to determine the actual atomic structure of the proteins so we can figure out how they work. Okay, so that's it. That's what you got for this week. Looking forward to talking about this with you guys, and have a great week. Okay, bye.